So we're doing section 3.5, examples 1 and 2 on page 117. Go ahead and open your books to page 117. The first thing they do is they give you some definitions, and they talk about the change. The change is when you're figuring out certain amounts, what was the change from one amount to another. For example, if I had started off with 5 books, 5 books. I'm going to abbreviate here. 5 books. That's what we had. And then now today we have 7 books. What was the change? Well, you're going to take the new value, which is 7 books, subtract it from the old value, and you end up with 2. So it changed. What did it change? It changed from 2 books, right? Went from 5 to 7, so it changed from 2 books. So the change is taking and subtracting the old from the new, and instead of saying old, you could say the original value to the new value. So that's the change. But what's new here is percent change. Percent change shows the change that has a percent of the old value. So basically, it's a ratio that you start off with, and it's going to be the ratio of the change of the old value or the change of the original value, however you want to verbalize that. So you do want to have this on your quick reference. What is the percent change? Percent change is the change divided by the old value, and it also is written as a percent. So if I was to do this change right here and do it as a change percent, it changed to, and the original value or the old value was 5 because we started out with 5 books, right? And you go ahead and divide this, and you're going to get 0.4. And now you remember we want the change percent because this equals the change percent. So we're going to move our decimal over 2 places and add a 0. All right, so we move it over 2 places. When we do that, we get 40%. So the change was 40%. As far as we got 40% more books. That is the amount of change over the original. Now, in your book, it's teaching you to do this. Take the 2 and the 5 and multiply it by 100%. Well, 2 times 100 is 200, right? And 5 divided by 1 is 5. 5 goes into 200 40 times. And remember, we're dealing in percents. So your answer is 4%. You could do it either way. It does not matter. Your decimal's here, 0.4, you move it over. When you are moving your decimal over by 4, really what you're doing here is you're multiplying this by 100 so that you can get a percent. That's actually what you're doing. This is showing that you're multiplying by 100, and this is just, well, I know when I multiply 100, I just move over 2%. So this is what you're actually doing. And so you could work that problem either way, but I just want you to understand that really what you're doing is you're multiplying by 100%. Why is that important? Why is the percent change important? Well, if you consider a product that had a price increase, let's say the product increased by $10. So that's the change. They're actually giving you the change. You didn't have to find it. A product was increased by $10. Would that be a significant change? Well, it really all depends. It depends on how much what the product is and what was the original value of the product. So let's look at 2 different scenarios. Let's say we have a $1,000 PC and we have a $5 notebook of paper. And I'm just going to write paper, notebook paper. Okay, if I write notebook, then you're going to think of an iPad notebook type thing. So we have a $1,000 computer and we have $5 notebook paper. And well, what if we increased this price? Instead of selling it for $1,000, we decided to sell it for $1,010. What was the percent change? Well, let's find out. Percent change. And you know, even though in your work you don't have to write percent change, doing that on the first few problems, it helps when you write it out, getting that into your brain. You see it, you say it, you write it, it's going to stick a little more. So what is the percent change? Okay, it's the change, right, over the original or the old value. Okay, the old amount. So to me, it's the change amount over the old amount. So it's kind of however you want to verbalize it, however that sticks in your brain. Okay, so we're going to figure that out. Here's our $1,000 PC. The change they told you was $10. The old amount or the original amount of the PC was $1,000, correct? We are going to multiply this by 100%, this ratio. Anytime you multiply 1 with several zeros, okay, it's going to be 1 times anything is anything, and you're going to have the same amount of zeros. So 10 times 100 is 1,000 over 1,000. Well, 1,000 over 1,000 is 1, and we're dealing in percents. So 1%. So the computer, when we added $10, we only increased it by 1% of the original value. Let's look at the notebook. $5. All right, let's do it. So we have $5. The change was 10. That's still the same change, but the original value was 5. We're going to multiply that by 100%. We're going to get 1,000 over 5. 5 goes into 1,000. Well, 5 goes into 10 2 times, right? Think it that way. 5 goes into 10 2 times. Add your 2 zeros. So we're going to get 200%. So if we add $10, we've increased the amount from the original value 200%. Here we only increased it by 1%. The change was the same. What made the difference is we compared it to the value. So yeah, this would be a big deal. I would not buy a notebook paper for $15. I would be upset if I knew it used to be $5 and now they're asking $15. If I went into a computer store and I knew that the PC was $1,000 and they only increased it by 1% to $1,010, it wouldn't bother me so much. So that's why understanding what the percent change is important. Now let's look at example 1. And I'm going to go ahead and get rid of anything to do with the other problems. All right. So example 1, it says, a baker decided to raise the price of a loaf of bread, his specialty bread. He went from $3, okay? He went from $3 to $4, right? So the change, he went from, I'm going to subtract the original from that, the change is $1. That's how he's increased his bread, is by $1. The new price resulted in a large drop in sales. So he reduced the price back to $3. In other words, people didn't want to buy the bread for $4. So this is the way he went here. He went from 1 to here. They didn't sell. So the next thing he did is he went back to $3. Notice the change here is $1, right? And the change here is $1. So the change is the same in that scenario. It says determine both, the word both, so you got 2 things you're going to find out. Determine both the percent increase and the percent decrease. Here he increased Let's just write that. He increased by $1. Here he decreased by $1. So they want you to figure out both. So the percent increase. I'm going to write this percent increase. Let's see what that is. The percent increase change, okay? So we're talking about the increase of change. So looking at our formula, what was our change? Our change was $1. Our original value, it went from 3 to 4, so we're going to write that over 3, right? And then we're going to go ahead and multiply that by 100%, which gives us 100 over 3, which gives us 3.3. Now we're talking about percents here. So if you want, you could approximate that because that continues out and just say 33%. Approximately 33%. That was the increase of the change. Now let's look at the decrease. So now they're asking for the decrease percent change. Well, the change was still $1, so it just decreased by $1. The original amount from here to here is the $4 amount. Okay, now I'm going to do the either way. I could convert this. The reason why I chose not to make that multiply by 100% is because I know, I've memorized this, that 1/4 is 0.25, and I would encourage you to memorize what 1/2 is and 1/4 and those kind of things as far as decimals go. And actually you may have memorized 1/3 is 33.3333. So because you're going to find that an SAT test, ACT test, or when you go to college, they might end up using similar ones, okay, in the testing process. So that is 0.25. Now all I've done is gone from a fraction to a decimal, but I need to make it a percent. So when I make it a percent, I'm going to move it over 2 places, and I get 25%. So there's 2 different ways you could show your work. You would get the same answer. In fact, let's just show you again. If I took that and I multiplied it by 100%, okay, I'm going to get 100 over 4. Well, 4 goes into 100 25 times, and we're dealing in percents. So you get the same answer, right? So you notice that there is, well, you're saying, well, the change was the same. Why do we got different percents? Okay, well, because we're using different original values. So it's obvious 1/3 is not the same thing as 1/4. All right, so the percents are not the same. They don't have the same base or the same original number. Let's look at example 2. So basically this lesson you are applying, you already know how to do ratios, decimals, and percents. You've just got a new formula here called the percent change, and what does that mean? That's the only thing that's really kind of new here. So number 2, it says last year 1,506 people voted last year. This year 912 people voted this year. All right? So what is our change? Well, let's see. Our change is what we are taking the new amount. We're going to subtract. So the change is 144. In other words, but did it increase or decrease? All right. Well, if you don't know whether it increased or decreased, here's a way that you can know. Well, let's just do it. I went ahead, I wrote it this way because it's easier for me to subtract this from this because this is a larger number and I don't have to do all that borrowing, right? But you look at this and say, okay, this was last year, this was this year, it decreased, right? If you look at them, it decreased, all right? But if you wanted to really represent that the right way and use this correct formula, it's saying keep the new. Well, what's the new? The new is 912, subtracting the original, all right? And you're going to do all this manipulating, and you're going to end up with a negative number. So that's this is the actual way to do it, which when you get up to negative 144, that actually tells you that it decreased, okay? But if you look at this way, then math is a lot easier. You just have to ask yourself, was it increasing or decreasing? And the question says, find the percent of decrease to the nearest tenth in votes. So we're dealing with decrease in votes. So our change was 144 because we're doing the absolute value of the change. Okay. So the change was 144 over the original value. That was our original. That's what we started with. Correct? And you can multiply this by 100%. So let's go ahead and do that. I'll show you the two different ways. So we can multiply that by 100%. Gives me 1400. Whoops, missing a 4. Thought you were going to earn a ticket on that one, didn't you? Okay. All right, divide that out, and you get 13.63, and it goes on. And they said go ahead and sort of approximate. It says to the nearest tenth. So you're just going to go one decimal place out. They told you go ahead and do that. So that's 13.6. So it decreased by 13.6%. Okay. The other way that you could have done this is you could have taken this right here. I'm just, like I said, you divide that, and when you divide that, you get 0.13636. I mean, it kind of goes on out, right? But we have to make it into a percent, so it means we have to move our decimal over 2 places. So now it becomes 13.6 whatever percent. That's example 2. Now I want to give you a practice problem. So here's our practice problem. And once I give it to you, remember, turn the video off. Just stop it and pause it. And come back, check your answer, and we'll work it together. I'm going to give you 2. The first problem, I want you to find the percent change from 40 to 50. So I want you to find the percent change. And the second problem, so go ahead and do both, is I want you to find the percent change from 50 to 40. So go ahead and work these problems and then come back and see if we've got the same percent that I did. All right. Welcome back. Okay, the change is 50 minus 40, which is 10. By the way, it's the same thing here. All right. And the percent change is the change over what we originally started with. We started with 40. And I'm going to do this one here just so you can kind of see my consistency here. The percent change was, well, the change was 10, but the original amount was 50. Okay, so we're going to end up with two different answers because our original amounts are different. Well, this here reduces to 1/4. I know 1/4 is 0.25 because I have it memorized, and I want you to memorize. 1/4 is 0.25. I'm going to move my decimal over 2 places, so I get 25%. So the change here was 25%. Now, this one, if you haven't memorized what 1/5 is, okay, so let's assume you have it. Let's go ahead and multiply this one. Let's use this method here. Over 1, and we're going to get 1,000. Whoops. Over 50. Well, 5 goes into 10, 200, right? You got this 1 0, so 5 goes into 100 20 times. So you get 20%. Okay? So you should have gotten 25% and 20%.